All right, welcome to this explainer. Today, we're tearing down what might just be the most brilliant strategic playbook in the entire semiconductor industry right now. We're looking at analog devices, or ADI, and their massive growth ambition to capture value in the middle of this historic AI boom. And you know what the secret is? They aren't even designing the compute chips. Instead, they're building the absolutely critical physical infrastructure, essentially the vascular system that makes those GPUs actually function. By the end of this, you'll see exactly how ADI has positioned itself as the indispensable bridge between the physical and the digital worlds. So here is our game plan for today. We're going to define the AI power bottleneck, unpack ADI's dual engine strategy, look at centralized power, explore the intelligent edge, dive into the connectivity layer, and then wrap up with the financial impact. Let's dive in. Okay, part 1, the AI power bottleneck. Let's look at the macro constraint. I want to throw a really pivotal question at you right out of the gate. What is actually the primary constraint to AI scaling today? Now, a lot of people might say, oh, it's advanced node manufacturing or it's theoretical silicon design, but it's not. The core bottleneck right now is physical electrical delivery. We're quite literally running out of ways to push enough power into these high-density AI clusters without melting the systems down. ADI's CEO and chair, Vincent Roche, really hit the nail on the head here. He said, AI infrastructure is fundamentally reshaping how power must be delivered, with energy now one of the most persistent constraints to scaling next-generation systems. Basically, as these AI models scale up, the thermal limits are actively threatening to break the whole system. To put that into perspective, just notice the shift in metrics we're seeing. We used to measure data center capacity purely by how fast they could compute, right? Flops and tops. Well, today, capacity is measured in gigawatts. AI workloads are surging from your standard 120 kilowatts per rack to a projected 1 megawatt per rack by the end of the decade. At that massive scale, you can't just throw more electricity at the problem. You need a highly engineered, system-level, grid-to-chip approach to extract maximum compute out of every single watt. Which brings us to Section 2, ADI's dual engine strategy. This is their overarching solution to this massive industry headache. If you look closely, ADI is utilizing this classic, beautifully executed barbell strategy to fuel their growth ambition. On side A, you've got the centralized engine. This is the massive, grid-to-core power architecture feeding those huge hyperscale data centers. Then, way over on side B, is the decentralized engine, software-led edge AI that's pushing ultra-low power, real-time control way out into industrial sensors. So they're strategically positioning themselves to dominate both the massive core and the highly dispersed edge. All right, Section 3, centralized grid-to-core power. Let's see how they're solving that macro bottleneck. So for years, traditional 48-volt architecture has been the gold standard. It's safe, it's reliable, but for megawatt AI racks, it totally hits a physical wall. The cabling gets way too unwieldy, and current surges create these massive inefficiencies. So the industry is forcing a migration to an 800-volt DC architecture. Higher voltage means lower current, and that means you can use smaller cabling, suffer less resistive power loss, and crucially, you can disaggregate those bulky power units into separate sidecars, which frees up super valuable rack space for more GPUs. But to truly win in this high-powered arena, ADI had to make a really bold move. $1.5 billion. That is the all-cash purchase price for their recent acquisition of Empower Semiconductor. So why drop $1.5 billion? They acquired Empower to get their hands on some breakthrough tech called integrated voltage regulators, or IVRs. See, delivering high-density power at the actual point of compute is just an absolute engineering nightmare. But Empower's technology actually sits directly beneath the AI accelerators, feeding the current vertically. It's wild. This completely shrinks the solution footprint, bypasses all the usual circuit board bottlenecks, and get this, it can cut total system power consumption by roughly 20%. So ADI is now managing power vertically right at the silicon. Now, there is a catch. 800-volt systems are inherently dangerous. Doing live tray maintenance at that voltage introduces severe risks of high-energy arcing, basically giant catastrophic sparks. And that's where ADI's high-voltage hot swap controllers come in. They are the crucial first line of defense at the 800V rack interface to manage those in-rush currents safely. But they don't just protect. They also observe. They're delivering real-time telemetry for voltage, current, and temperature. And by analyzing that data, operators can actually shift from a reactive maintenance model, fixing things when they break, to a predictive one, preventing the outages before they even happen. Okay, moving to section 4, decentralized, the intelligent edge. We're zooming out from the massive data centers to the industrial extremities. ADI defines this whole area as software-led edge AI. Honestly, making tiny edge devices smart without draining their batteries is a huge software and deployment hurdle. But through platforms like CodeFusion Studio, ADI is drastically simplifying how you prototype embedded systems. They're basically providing the exact environments developers need to build intelligent edge systems that are capable of ultra-low power, real-time control, so these tiny devices can sense and respond to real-world conditions completely autonomously. Which brings us to section 5, the connectivity transit layer. How do these two extremes actually talk to each other? Well, here is the strategic flow of data across this new vascular system. Step 1. The telemetry is captured and prioritized locally at the edge using their Max 7800 AI chips. Step 2. That data is transmitted seamlessly over long distances via industrial Ethernet or high-speed Wi-Fi. And then step 3, it arrives at the centralized cloud, which is powered by ADI's grid-to-core infrastructure for all the heavy processing. The specific hardware making this transit layer possible is just fascinating. First up, you have the Apollo MX-FE, which is 16-nanometer software-defined RF, pushing the boundaries for 6G and enabling Wi-Fi 7 for mission-critical real-time control at the edge. Second, there's their Cronus technology. Get this. It allows a single twisted pair cable to transmit both high-bandwidth data and power over a full kilometer directly to edge nodes. And finally, Software Configurable I/O, or SWIO, which essentially turns your standard legacy factory cables into modern Ethernet data arteries. All right, final section, number 6, shaping AI's physical future. What does this look like financially? Take a look at this staggering stat from ADI's Q3 2026 earnings. 80% of their communications revenue is now driven entirely by data center demand. I mean, this just proves how aggressively and successfully ADI has pivoted its business directly into the heart of AI infrastructure. Their optical and power growth is actually exceeding 100% year over year. And this timeline is basically a masterclass in strategic discipline. Look back at 2007. ADI made the hard choice to divest its consumer cellular basebands to MediaTek, specifically so they could focus on these high-margin industrial and infrastructure sockets. Flash forward to Q3 2026, and wow, that discipline is paying off. $4.02 billion in revenue, up 40% year over year, with an incredible 50% operating margin. And they are already targeting to double their optical circuit switching revenue again by 2027, based on their current design wins. They have massively expanded their serviceable addressable market. So as we wrap up this explainer, I'm going to leave you with this somewhat provocative thought to chew on. As AI models just keep growing infinitely, is power actually the new true measure of compute? We spend so much time obsessing over digital logic, but ADI is out here proving that the ultimate ceiling for AI is, for sure, physical. By owning the plumbing, the vascular system, they've shown that the foundation of the digital revolution is, ironically, entirely analog. Thanks so much for learning with us today, and we'll catch you next time.